Okay, so for number 37, if x is odd, then x plus 1 is even. Well, that's true. If you have an odd number, the number right after that is going to be even. So the sum of two odd numbers is even. So it'd be like 1 and 3 is 4, and so forth. So if we did that, you would see that two odd numbers always add up to be even number. Then the difference of two even numbers is positive. So, for instance, if different, so I could say like 2 minus 4, that would give me -4, and that is not positive. And finally, if x is positive, then the opposite of x would be negative. So for 37, that is C. Okay, so let's take a look at this next one here. So this asks us to make a table of values for x squared plus x plus 11, where x are the integers from 1 to 8. So I'm going to go ahead and just set up my table here. Okay, so first one, that just ends up being 13. Next one is 2 squared plus 2 plus 11. That equals 17. Then 3 squared plus 3 plus 11 is 23. Then I'm just going to continue that for the rest of this table. Okay, so what I'm noticing here is that all these numbers are odd. So I'm going to make a conjecture that for all positive integers, x squared plus x plus 11 will be odd. Now the next part says to continue the table, and then what value of x generates a counterexample. So this is assuming that if we keep going, we'll find something that is counter to what my conjecture is. So I'm just going to continue this for a few more numbers. Okay, so as I did this, I'm noticing they are still odd. But and then I took a look in the book to see what this could be, and they mentioned that the first 9 are actually all prime numbers. And then the first non-prime number is number 10. It's not prime. So based on the way the question was asked, my conjecture was correct, and it looks like it would be continued to be correct. I did not check negative numbers that could possibly affect things, but what the book was thinking I would do is notice that all those are prime and then find the first non-prime number.